Welcome back to Investigation 4.3 or Problem 4.3, interpreting four-quadrant graphs, pulling it all together. Let's go. Okay, so I pulled the graph from the previous page and it's here, and then here are the questions that go with it. So let's just go on this. So question one, what is cold temperature in both Celsius and Fahrenheit? What is a warm temperature in both? So let's start with that cold. Let's see. How about 20 degrees Fahrenheit, which is about minus 7 degrees Celsius. And then how about for a warm one, let's go with, let's see where we'll cross here. So how about 20 degrees Celsius, which is just like 68 degrees Fahrenheit. All right, question two, if water freezes at 0 Celsius, what is the freezing temperature in water in Fahrenheit? So here's 0 Celsius. We're going to come across. It's just past 30, so it's 32. All right, question three. If average body temperature is 98.6, what is the body temperature in Celsius? All right, so 90, this is going to be 100. So we're looking right about there. Come up. That's going to be right about 37 degrees Celsius. Okay, for the next question, are the temps in Celsius and Fahrenheit ever the same? Well, I can't see that on this graph, but on the thermometer, if we look at minus 40 Fahrenheit is also minus 40 Celsius. All right, question 5. What temperatures are in quadrant 3? When might they be important? So this is quadrant 1, quadrant 2, quadrant 3, and then of course quadrant 4. So when temperatures are negative, are in the negatives, both would be in the negatives, both Fahrenheit and Celsius to be in quadrant 3. And when might they be important? If it's extremely cold weather, like in Antarctica or when we have the polar vortexes. All right, so question 6, why are there no points in quadrant 2? So in quadrant 2, you would have negative Fahrenheit, but positive Celsius, and that's never going to happen. So there can't be any points in quadrant 2. Question 7, for what temperature is Celsius less than or equal to 98.6? So that basically goes back to the third question, and we said that was 37, so it would be Celsius is less than or equal to 37. And I'm going to go ahead and skip question 8 for time's sake in the video. Okay, so situation A, we have 2 stories. The daily profit or loss of an outdoor skating rink depends on the daytime high temperature. And story 2, the daily profit or loss of an amusement park increases as the number of paying customers increases. So for each story, decide what is the independent and dependent variables are. So in story 1, the temperature is the independent variable and the profit is the dependent variable. And in story 2, the number of paying customers is the independent variable and the profit is the dependent variable. All right, which graph represents the story? Well, story 1 looks like it could be this one. So profit would be here, temperature would be here. If it was extremely cold, not a lot of profit, people aren't going. As it warms up, you're going to get a more profit, but because it's skating, if it gets too warm, the profits are going to tail off because now you don't have a rink. Whereas this graph shows story 2, the number of people, as it increases, the profit goes up. So we have the profit is on the y as well, and on the x will be the number of people. As it goes up, as a very linear graph, the amount of people goes up, the profit too goes up. And then how could you label the graph so that someone else would know what it represents? So in both of these graphs, we're going to put profit on the y, and on graph W, we're going to put number of paying customers on the x, and on the graph Y, we're going to put temperature on the x-axis. All right, so in situation B, we're looking at this example of a tow truck company, and it says for very low and very high temperatures, we will have more customers. This means that our profit will increase. For temperatures in the cool but not cold and warm but not hot range, we will have few customers. This means that our profits will decline. So first we got to know, it's asked us what are the variables. And so we have two variables, the temperature, which is the independent variable, and we have the number of customers, which is the dependent variable. All right. Now we have to sketch a graph that shows the pattern of change. So let me do that and I'll be back. All right, so here's my graph, and there's other ways you could do this, but for what I want to point out is here's a high number of customers, very low temperature, right? Extremely cold. As it warms up, less customers. As it gets hotter, again, more customers. And then lastly here is how would your graph change if you use Celsius temperatures as opposed to Fahrenheit, because this was in Fahrenheit? Well, it's going to look very similar, but if we use the same scale, with Celsius, the curve may seem less flat because the temperature changes wouldn't be as drastic as you would see with Fahrenheit. All right, let's move on to the next situation. All right, so in situation C, we have this chart full of thermometer temperatures in both Fahrenheit and Celsius, and it's asking us to put the display, put one of the display color temperatures on a number line. I went ahead and I'm going to show you both in Fahrenheit and Celsius, all the different numbers, okay, or the different colors or displays. So if you were to place, so that was number one. Number two, if you were to place each display color temperatures on a number line, which color would have the longest segment? Well, you can see, and it doesn't matter whether it's in Fahrenheit or in Celsius, the blue has the largest, would be the longest on the number line. Number three, to test accurately of the thermometer, you can take two readings. The difference between the larger and the smaller of the two readings should be less than or equal to 6/10 Fahrenheit. Quan took two readings. He got 98.2 and 97.4. Does this thermometer seem to be accurate? So we have 98.2 and 97.4. So let's find the difference there. So 98.2 and 97.4. So that's 0.8. And it needs to be less than or equal to 6/10, and we have 8/10. So, does it seem accurate? I would say no, because it's outside of the standard deviation or of error, because it is more than 6/10. Okay, and then number four, looks like there's a little typo here, but basically what it's saying is the temperature could be plus or minus 4/10. So if the thermometer reads 98.7, what are the possible temperatures? All right, I'm going to just draw a number line here for this, and I'm going to put 98.7 in the middle. So we could go 4/10 up, so 1, 2, 3, 4. We could also go 4/10 down, 1, 2, 3, 4. And so this could read anywhere between, let me make this a little bigger so we can actually see these numbers. So if 98.7, it could be 98.8, 98.9, 99, and 99.1. Or it could be 98.6, 98.5, 98.4, I'll put that down here, or 98.3. All right, and that's the end of the investigation. I hope this video was helpful, and I will see you in the next investigation.